All right, for 4.4, we're talking about scatter plots and lines of fit. All right, what is a scatter plot? It's simply two sets of data put together on a coordinate grid. And in this case, the two sets of data we have are calories and sugar, grams of sugar, that is. All right, so for example 1, it says a scatter plot shows the amount x in grams of sugar and the numbers y of calories in 10 smoothies. All right, so we have 10 different points on this graph here. How many calories are in the smoothie that contains 56 grams of sugar? All right, so let's go to grams of sugar. That's the horizontal line here. And 56 would be right in between 54 and 58. So that takes us straight up to this point. And that would give us 270 calories. So for a 270 calorie smoothie, there's 56 grams of sugar. So the answer for part A is 270. All right, for part B, how many grams of sugar are in the smoothie that contains 320 calories? All right, let's go to 320. We're all the way at the top here. All right, and just go all the way along the side here. There's that point. Go down then, and we get the number of grams of sugar. So that's 70 grams of sugar. Then for part C, it says, what tends to happen to the number of calories as the number of grams of sugar increases? Well, you could see that for most of the smoothies, it seems that as the calories goes up, so does the grams of sugar. All right, so that's the general trend. So you would say as the number of calories goes up, so does the number of grams of sugar. Alrighty, let's go on example 2. All right, just a explanation here of an important concept that we're covering. Identifying correlations. All right, so correlation is a relationship between data sets. So as you can see, as x increases, so does y. All right, so this means that there is a positive correlation. But here, as x increases, y decreases. All right, if that's the case, that's a negative correlation. So here we have a positive correlation and a positive slope. Here we have a negative correlation and a negative slope. And here, no points show a pattern here. There's no pattern at all. So we say there's no correlation. All right, going to example 2, identifying correlations. Tell whether the data show a positive, a negative, or no correlation. All right, the points are scattered all over the place here. So part A, very simple answer, there's no correlation. All right, and for part B, temperature and coat sales at a store. All right, as we're moving to the right, what's happening to the points? All right, they're coming down. So as x increases, y is decreasing. All right, so that's a negative correlation. All right, since one is moving down. All right, very simple idea once you get the hang of it. And the last example, using lines of fit to model data. All right, so lines of fit is just coming up with a line that essentially represents the trend of the data points. Okay, so for example 3, let's just use a concrete example. Finding a line of fit. So the table shows the weekly sales of DVD and the number of weeks since its release. All right, write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and y-intercept of the line of fit. All right, cool. Let's see what we do here. Okay, so we have all these points. So here we have weeks, and then we have sales. So, for example, week 1, we had $19. That's that point right there. All right. So week 2, $15. All right, should make sense at this point. There's plotting all the points for us. Now here's a line of fit. So we're just drawing a line that generally passes through most of the points, or it's very close to the points. Okay, now we're going to figure out what the equation of this line is. Now, how do you do that? You just pick two of the points that the line passes through. In this case, we have 5, 10, and we have 6, 8. So this one will be our x1, y1, and this one will be our x2, y2. All right, so I want to come up with an equation to describe that line. So we always use y equals mx plus b. I need to figure out the slope. So I'm going to use y1, which is 10, minus y2, which is 8, over x1, which is 5, minus x2, which is 6. So I have 2 over -1, so I end up with -2. All right, so I have y equals -2x plus b. All right, now how do you figure out what b is? Well, you use either point. All right, I'll use 5, 10. Use the x and y values, and we have 10 is equal to -2 times 5 plus b. So I have 10 equals -10 plus b, add 10, and b is equal to 20. All right, so I'm going to have y is equal to -2x plus 20. All right, there's my line, or my equation that describes the line, and it says to interpret the slope and y-intercept. Okay, what does it mean? All right, the slope is -2. Well, relative to this graph that we have here, this is my slope. I'm going down 2, right 1 each time. So if I go down 2, right 1, what does that actually mean? When I go down, what does that represent? Sales in millions. Okay, so it just means every week sales go down $2 million. It's a lot of money. All right. And then what is the y-intercept? Well, the y-intercept, that's up here. That just represents when sales haven't even started yet. So in this particular case, since it's a real-world context, that number is insignificant. The slope is what's important. All right. So that's all there is to it. Working with scatter plots and then lines that fit into the scatter plot. All right, if you have any questions, make sure to ask. Begin the assignment at the bottom of the web page.